In this video, we're doing bounds and percentage error, and the whole topic starts from one idea. A rounded number isn't a number, it's a range. Look at these two. 24 sweets means 24 sweets. You counted them. But a rod measured as 24 centimeters to the nearest centimeter could actually be anything from 23.5 up to 24.5. Every one of those rounds to 24. The measurement doesn't tell you the length. It tells you the interval the length is in. Half the rounding unit, either side. That's the whole rule. So here it is in general. Take the unit you rounded to, halve it, and go that far each way. Nearest one, plus or minus 0.5. Nearest tenth, plus or minus 0.05. Nearest 10, plus or minus 5. Nearest hundredth, plus or minus 0.005. And notice the two different signs. The lower bound is included. The upper bound is not. 23.5 rounds up to 24, so it's in. But 24.5 rounds up to 25, not down, so it's out. You'll still see that number written as the answer. It's called the upper bound, even though the value itself isn't in the range. Now percentage error. It's the size of the mistake over the exact value times 100. Note two things. It's the exact value on the bottom, not the approximate one. People get that the wrong way round constantly. And the modulus signs on top mean percentage error is never negative. Example 1. A rod is 24 centimeters to the nearest centimeter. Find the bounds. The unit is 1, so it's plus or minus 0.5. The length is at least 23.5 and less than 24.5. Example 2. Other precisions. A mass is 4.5 kilograms to 1 decimal place. The unit is 0.1, so halve it, plus or minus 0.05. 4.45 up to 4.55. Now this one. A mass is 250 grams to 2 significant figures. And this is where people go wrong. 2 significant figures on 250. The last significant figure is the 5, and that's in the tens column. So the unit is 10, not 1. Plus or minus 5. 245 up to 255. Find which column the last significant figure sits in first, every time. Example 3. Percentage error. Pi is approximated as 3.14. Find the percentage error. Modulus of 3.14 minus pi over pi times 100. The difference is 0.001593. Divide by pi times 100. 0.0507%. And do that in one line on the calculator, not in stages, so nothing gets rounded twice. Second one. A shop estimates 500 sales. The true figure is 486. 14 over 486 times 100. 2.88%. And notice the 486 went on the bottom because that's the exact value. Example 4. Now put bounds through a calculation. A rectangle measures 12 centimeters by 8 centimeters, each to the nearest centimeter. Find the bounds of the area. The sides are 11.5 to 12.5 and 7.5 to 8.5. Smallest area uses both lower bounds. 11.5 times 7.5 is 86.25. Largest uses both upper bounds. 12.5 times 8.5 is 106.25. And look how wide that is. 2 measurements, each uncertain by half a centimeter, give an area uncertain by 20 square centimeters. Last one, and it's the trap. A is 20 and B is 8, each to the nearest whole number. Find the bounds of A minus B and of A divided by B. For adding and multiplying, biggest with biggest works. For subtracting and dividing, it does not. Think about what makes a subtraction big. You want A as large as possible and B as small as possible. So the largest A minus B is 20.5 minus 7.5, 13. And the smallest is 19.5 minus 8.5, 11. The bounds crossed over. Same for division. Largest is big over small. 20.5 over 7.5, 2.733. Smallest is small over big. 19.5 over 8.5, 2.294. So here's the rule. Whenever the operation makes the answer smaller as the second number grows, the bounds swap over. So a rounded number is an interval, and the interval survives every calculation you put it through. That's the last of the number and algebra core. The next 4 videos are higher level only. We're going to build a number system where the square root of -1 exists. Next video, complex numbers.